All right. So today's topic is logarithmic functions. This is the basics of logarithms. So we're going to be talking about, how to change something from an exponent to a logarithm and then some facts about it. Our objective for today is to write and evaluate log expressions. Redemption on the exit ticket, the quiz, and the final. A little bit of an overview of what we're going to be doing today. We're going to be going over how to change the logarithms from exponent form to logarithmic form. Then we're going to evaluate some logs without our calculator. And then we're going to use our calculator to evaluate some more tough logs using our change of base formula. That's kind of what we're going to be planning for today. And then that's it. You'll do your you-do practice, you'll do your exit ticket, and then you'll do your homework at the end. All right. Should be pretty easy today. Now, logs are something that was invented to help with really big numbers. So for a while, we did not have calculators that everybody could have or use. And so what they would have is what's called a log table. So in the back of a lot of books, there'd be a full list of a whole bunch of different logs, all the way throughout the different numbers and the different bases and everything, that you would then use some math to find out how big some number is, right? What exponent I should use. And this is before we had calculators. So it's a little different now in the fact that we have calculators that can do a lot of this for us. And so it's a little bit easier. We don't need that table anymore. So logs is a little bit, less useful than it used to be. But it still has some uses. It still comes up in some things like decay of some isotopes and stuff like that. You'll see a lot of logs, specifically our natural log, which we'll talk about later on in this unit. Some things like that. All right. So we're going to start with logarithmic functions, the basics of it. A logarithm base b of a positive integer number x satisfies the following definition. Log base b of x equals y if and only if b to the y equals x. Which is really the fancy way of saying if it's in this form, I can rewrite it in this form. Or if it's in this form, if it's like this, I can rewrite it like this. Or I can go between either form however I want, as long as I keep the numbers the correct place. One thing to know is that we read log b of x as log base b of x, where b is my base, just like over here. We use the letter b because of the fact that this is a base right over here, my base of my exponent. So we use the letter b, base. All right. There's a little typo here. There should be a b right here as well. So if you want to put that b in right here, you can do that right there. So let's go into actually some problems where we're actually using our logarithms. This is just the definition. Let's actually use it now. So when I do this problem right here, just like up here, my y goes to the other side, and my x gets next to my base. So if I'm looking at this problem right here, my 2 that was up here as an exponent is now my equal to part, right down here. And the 10, you can kind of think of as going down here, that little bottom part right there. And my 100 goes right here. Exponents by itself, the other two are put together. My base is still my bottom number. It's still the base of my thing. So it still goes down there. We do the same thing over here for b. Again, the 4, the exponent goes by itself. My 3 is now my base. And the 81 is next to the 3. All right. That's that process that we do. exponent by itself, base becomes a little base. This number comes right here. Are there any questions on either of these two examples before I set you free to work on C and D? Anybody have anything they want to ask about? Any questions? Anybody want me to repeat or go back over anything? Anything at all that someone seems to be missing? Or I set you free. All right, try and do C and D. I'll give you a little bit of time to work on those. Say about a minute, maybe a little over a minute to work on these, and then we'll go over them together. So you have a minute starting now. All right, so let's start with C. Who can tell me what I should do for C? Yeah. Good. 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 Perfect. Exactly right. Log base 3 of 27 equals 3. Perfect. Any questions on C before we move on to D? All right. Who thinks they can do D? Who can tell me the answer to D? Yeah. Perfect. Log base 4 of 64 equals 3. Perfect answer. Remember, my exponent gets left on its own. My other number comes down. My base stays below. Yeah. Are there any questions on C or D before we move on to our next section of evaluating each log expression? All right. Let's move on to A then. Right down here for example 2. I'm going to clear off my screen. I'm going to scroll down a little bit, leaving my answers up in case you want to copy them down. For A right here, what I'm going to always try and do is I'm going to try and make these two numbers, the 8 and the 32, have the same base. Okay? I can rewrite 8, I can write this nicely, as 2 to the third power. And I can rewrite 32 as 2 to the fifth power. You can do both of those things right there. And so when I rewrite these, now that they'll have the same base, I'll be able to do some extra math with it. Log base 2 to the third of 2 to the fifth, like this. So I forgot my equal sign right here. It's nice to have that. And then the last thing I'm going to do, this is a little bit of a, kind of think of it as a cheat code. You know, there's some actual math involved to get this to be your correct answer that we're going to go over next class. But for now, with this basic one right here, what we can do is actually take the exponent from this top part, put it right here, and the exponent from this bottom part, put it down below as a fraction. We'll learn why this technically works next class when we go over simplifying these log functions. But for now, this is how we're going to kind of do it. Now, this is one way that we can do this process right here. We can do kind of the cheater method where we take the exponents that we just found to be here and here, do that. We can also rewrite this equation right here with this right here. So I can also say this is log of 2 to the third times 2 to the fifth equals x. Trying to find out what this is equal to. And I can rewrite this using my log form as 2 to the third times x equals 2 to the fifth. Since our logs are the same, we can cancel those out and we just get 3x equals 5. We end up with x equals 5 thirds. This is another way you can do this if you don't like my cheater method. Right? Are there any questions on either way we did A or before we move on to B? Anybody confused about anything? Anybody having problems understanding how I got the 5 to the 3, how I got 5 to the third, and 32 to be 2 to the fifth, anything like that? So again, 8 to the 32, I can rewrite each one of those as 2 to some power for these ones. Because 8 is equal to 2 to the third, and 32 is 2 to the fifth. So I rewrote those right here. And there's some more complicated math involved to really get this answer right here, where we rewrite this as a change of base formula, and then we use our exponent rule to be able to pull it out front, and a bunch of stuff we're going to go over next class. But specifically to get this using our cheater method, we're going to change this to be 2 to the third and 2 to the fifth, and then we're going to exponent it out like that. That's a great question. Someone asked, what if the 8 was a 2? Then instead of 2 to the third, we would get 2 to the first, we would just get a 1 down here. Same process. It's a great question. Again, someone asked if this 8 was happened to be a 2 instead of an 8, what we would do. We could rewrite it as 2 to the first, get a 1 down here, and just get the answer is 5. That'll help you for C. Undo, 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 but that's not this problem, so let's get rid of that. We don't confuse anybody. Last problem we're going to go over before I set you loose is B. It's the same process. You got to rewrite 64 as some power. I can rewrite 64 as 2 to the 6th power. And then the 1 over 32 is kind of the more tricky one. This one gets a lot of people. 1 over 32 can be rewritten as 1 over 2 to the 5th. And whenever I want to have something on the top side of something, I can just move it up there by changing the exponent. So instead of 1 over 2 to the 5th, this is going to be equal to 2 to the negative 5th. All right, so whenever I want an exponent, whenever I want one of these on top, I can just change the sign to be negative, and then it's up top. So then I will get this right here. Take my two exponents, negative 5 and 6. I get negative 5, 6. Select this so we can move this out of the way. There we go. That looks nicer. There we go. Are there any questions on how I got B? Like how did I get 2 to the negative 5th? How did I get anything else? So 1 over 32, we can rewrite as 1 over 2 to the 5th. Whenever we want an exponent on the top so that it's just a 2, we can move it to the top by changing the exponent sign to be negative. So instead of being a positive 5, it's going to become a negative 5. That's what we do that right there. Yeah. Then like 5, we have our invisible number, an invisible 1, just like that. We always have an exponent everywhere. Now, later on, we will find that these two do not have something in common, and so we'll have to do a change of base formula, but we'll go over that later. For now, we've chosen ones that do work out so that we can kind of do this process and get practice on our own. Are there any questions on A or B before I set you loose to work on C and D? All right, let's try it out. Try out C and D. Let's go a couple minutes on the clock. Let's go 3 minutes on the clock, see how you do, then we'll go over it. All right, 3 minutes starting now. All right, let's go over our change of base formula now. So we just went over C and D. We have our change of base formula now. So before we can use our change of base formula, we got to talk about the type of logarithm your calculator uses, and that's called our common logarithm. Right? Our common logarithm has a base of 10, and it's always written without the base. So whenever you see no base like this one, log x, just know that there's an invisible 10 right down here. Right? Excuse me. This is the log button on your calculator. Some of you guys might have a really fancy calculator that actually has a log button that has the ability to use bases, but most of them use this right here. No, you can just, so I'll show you right here how you're going to use it. You don't need to. Depends on what calculator you're using too. Like if you're using an iPhone, they have to do a lot of extra steps to do it. If you're using a big old graphing calculator, you don't have to do as many steps. Perfect. All right, so some logarithms are not as easy to evaluate as other ones. Like before, we were talking about ones with the same power, but sometimes they don't have the same power, like 3 and 29. For those ones, we have our change of base formula. Our change of base formula takes the outside number and it changes it to the top number. Right? And then our base is now the bottom one. Now, I specifically put this as our base 10 one, but it doesn't have to be our base 10. This could also be equal to fraction bar any other log base as long as they're the same. I could do log base a to the a over log base a to the b. As long as these two buttons are the same, as long as the two bases are the same, I can choose whatever two I want. All right. Which is nice for us. Now, this is pretty easy to see now, log base A over log base B. We specifically use this one because of the fact that that's what our calculator can use. All right, that's what we can plug into our calculator and simplify. Let's do that now. For A right here, we're going to put it into this calculator right here. Clear all, don't need them right here. I go log. I can either include the parenthesis or not. 29 divided by log 3. Now, what I would like everybody to know is that I like it when we round to 2 decimal places. To round to 2 decimal places means that we look at our third number, our third decimal, and we look to see if it's greater than or equal to 5 or less than 5. If it's equal to or greater than 5, we round up, and so our answer will be 3.07. All right. We can do the same thing over here for log 20, 15. Log base 20 of 15. Again, return log base 20. Again, I could include the parentheses if I want to. Oops, that's not right. 15 over 20. parentheses don't actually matter either way. I get 0.903. Since this 3 right here is less than 5, I round down to 0.90. And the reason I stress this is that a lot of the times when we're grading these things, I might have a fill in the blank problem on a test or something. And if you were to plug in 3.06 right here, or just 0.91 or something like that, and you get it wrong, I don't hand grade those, so it might actually mark you as wrong. Right? So you have to make sure that you are rounding correctly. If you ever have a question about rounding, I can help you with that. That's not what we're teaching right now, so I'm fine with helping you with rounding and everything. Just let me know on a test or whatever. And then finally, we have our last one, log base 4 of 32. Log 4. Nope, that's not right. Log 32 divided by log 4, 2.5. Now, if you are using some other calculators, you might have to put parentheses around this bottom log right here when you're dividing. It all depends on your calculator. So if you're getting this, you're plugging it in, you aren't finding that you're getting the right answer, the one doesn't match me, then it's probably because you need to put parentheses around it. If you're wondering how to do it on a phone calculator, like if you have an iPhone, you would have to go something like, you have to type in 32, then you'd click your log button. Then you would go divided by button. Then you would go parenthesis, because you need to be able to put this in a parenthesis. Then you would type in 4. Then you would click your log button again. Then you would type in parenthesis, and then equal sign. And that's what you would have to do to be able to plug into your calculator for an iPhone. Go through that whole process. They do. So please, if you are currently using an iPhone calculator for everything, maybe switch over to something else. Right? I can't make you, but it is a good idea. So we have our 3 values. Are there any questions on A, B, or C before I set you free to work on D, E, and F? Let's put about 2 minutes on the clock. We'll see how you do over those 2 minutes, then we'll go over this problem. You have 2 minutes starting now to work on this. All right, so let's go over these answers right here. We'll start with D. Who can tell me the answer for D? Tom, you got the answer? All right, so let's do it together right now. Return, so we got log 29, so all I have to do is if we're using this Desmos calculator, just type in log, put my number, and I just come over here to the divided by symbol, and I type in log 5. And that gives us this. If I rounded that, what does that become? I was guessing, you probably can't see. So it's 2.092. How would I round that? So our number is 2.092. How would I round that to 2 decimal places? So when I round, I'm looking at 2 decimal places and I look at the number after it. If that number is greater than 5, I round up. If it's less than 5, I round down. So since this is 2 and this is less than 5, I'm going to round down. And so this just becomes 2.09. All right. Let's see if someone else can give me E. You can tell me what my answer for E should be. Yeah. All right. Can anybody else give me an answer to number E? I think I got an answer. Perfect. 1.84. Correct answer. We'll do one more. Last one. Who can tell me the answer for the last one? Ooh, that's close. Not quite though. Perfect. 1.33. Because my number is 1.330. And since this is less than 5, I round down to just 1.33. Nice and easy that way. Remember, I only round up if the next number is 5 or greater. If not, I round down and just take the regular number. Are there any questions on D, E, or F before I set you free to work on the you do practice and all that? All right. You have the rest of class to work on the you do practice, the exit ticket, and the homework. Let me know if you have any questions. I'm here to help.